All right, happy Sunday, everyone. Welcome to live stream number 6, or is it, or 6.5 after last week's fiasco. We're going to model, or we're going to stress, excuse me, we're going to stress test the Gib Crane. Or Jib Crane. I'm sorry. Keep on getting that messed up. Um, we went ahead and remodeled all the parts. I don't know exactly what happened last week. Um, we drew it just like I did before, and everything's worked fine this earlier today when I tried it. But who knows? It can change again. Anything happens when you're doing it live. But I thought I'd give you a little update of what we've been doing last week. Um, we got the parts washers pretty much completed. We put the drain pans on it. My brother came over and did some welding. So, come on, Google Photos. Why aren't you working here? He came over and did a little welding. Got all the those are the, I reckon catch basins would be the best word to say for him. So he came over and laid down some pretty good welding, and got all that stuff done. Um, we got all the bungs welded in. Here's some pictures of some of his welds. So he does a good job. Um, and here's a little tip for you. Don't ever throw away your office chairs. Take them out to the shop. They make good roll-around chairs. And then we filled it up with water, and I have an aeration device that we built that we stuck into the bottom of it to provide some circulation and agitation. It's just hooked to the shop air through a gate valve, and that just provides the circulation and the aeration for it. It works really, really good. And today we had to work yesterday, so today I went out to the shop this morning and went ahead and made a lid for it. I don't have any pictures for that, so we'll do that next week. But it does some pretty good aeration, I do have to say. So with that, let's go ahead and get started into this week's live stream, or what we're going to do, I should say. Somebody asked last week in the chat or emailed me or something where I get the CAD sections from, and I get all my metal CAD sections from cadsteel.com. If you click on the menu or on the menu on the top and go through the CAD sections, we're going to get an S-shaped beam. It's just an American Standard beam. It gives you all the measurements right here, and we're going to get an S4 by 7.7. So right here is all the measurements that beam has, and you can just download the DWG file or the drawing or the DXF file. In this case, it's DWG, which is AutoCAD standard. Well, here, let's just do it. I'll download it right quick. You just save it, and then you open up. I'm going to switch screens here. Oh, if you can see it, I apologize. Let's go back here. cadsteel.com, and you click on the menu section, and then click on the Steel Sections area, and go to the S shape, or any of the shapes that you need, but I needed the American Standard beam shape. So, and it has all the CAD models for it. So you just click on the one that you want, in our case the S4 by 7.7, and it's that you can download the zip file or download the DWG file, which is AutoCAD standard drawing. So I downloaded the AutoCAD file. It's right there. So let me move that off to the side here. And then to upload the file into Fusion, you click on Upload, and all you have to do is drag it over into the box and upload it. Just hit upload, and Fusion does all of its storage in the cloud, and it has translators. You can download CATIA models, NX models, SolidWorks models, just about any kind of model you can upload into there. It'll translate it for you. So I've already done that, and here it is. It's this S4.7.7. And then to bring it into the drawing, once it's uploaded, all you have to do is drag it into it, and it's in there right here. I've zoomed it in so you can see it, and right there it is. And then you can double check it. I'm going to try and get both of these on the screen at the same time. Maybe not. So let's just measure. This top part is this 2 5/8. So if I go over here and hit inspect and measure from, let's see, this point to this point, 2.66. So we're right there. So we know that the drawing is correct. So I'm going to go ahead and hide it back in the drawing here, and then go back to what we were going to do. So I redrew everything, from the hinges to the I-beams and all the other parts, and I put it back together. And what we have to do now, excuse me, is create this where we're going to do the test at, which the weakest point would be way out here at the end. So we need to create a way that I can just choose 8 inches or 10 inches. 8 or 10 inches. Now I can't remember. We'll make it 8 inches of this area right out in here that we're going to simulate where the load is testing on that bottom flange. So I went to Harbor Freight, and I've got one of their inexpensive I-beam dollies, I reckon you call it. And what I need to do is get some of that, or simulate where that weight's going to be at. So what we need to do is construct a couple of planes here so that we can make a clip plane in here. So if you go up to construct and hit offset plane, and then it's actually asking you which plane do you want to offset, and we want to offset this plane right here, and we want to go back about 2 inches. So I'm going to click -2 inches. And the reason I went back -2, I'll turn those on so you can see it, because it's kind of hard. I'll leave it on. It'll be all right. So right there is the new construction plane we just created. And the reason that I'm going back 2 inches to begin with is at the end of that beam, I need to insert a pin to keep that dolly from sliding out and dropping off onto the table. Well, with a load on it especially, but I don't want all the crane or the chain fall or the winch or whatever we're going to have up there to fall off. So we're an inch back from the end. We're going to drill a 3/4 hole and put a pin in. So that's the only reason that I'm going back and doing that. So now we have the first plane, or first construction plane, done. Now we need to add the second construction plane. So again, I'm going to construct an offset plane from that face back 10 inches this time. So now if we look kind of off to the side, you can see, let me zoom out here, you can see both those planes. And this is where we're going to create our space that we're going to simulate the load on. So when you get to this point, you want to make a split face. You want to split the face. So you just click split face, and then it says what faces do you want to split. So you want to split this one, and then we got to rotate, and then we're going to do this one, because the dolly, rests on both sides of that beam, so you need to do both sides. And then the splitting tool, and where do you want to create the split at? So if you hit select, and instead of this plane and then this plane, so that you could do it that way, or the way I normally do it is I'll go over here to where my construction planes are at, and I'll just choose these 2 planes. Either way, it gets those 2 planes chosen. So you just hit OK. So now you can see the 2 lines. Let me hide these constructions right here. So we have a face here and a face here. And that's what we're going to use to do our testing with, hopefully. So I believe I've got everything ready, drawn, and we're good to go, I hope. So out of this environment, I'm going to go ahead and save my file. We're going to switch over to the simulation file. And then again, it's going to ask us what kind of stress or what kind of test do we want to do. We want to do a static stress test. So we're going to fill out this whole thing again like we attempted to do the other time. The material is already defined, because the way I draw, let's go back to the model right quick. I define all my material at the very beginning. So I created at the very beginning when I started drawing it, I defined my material. So in this case, our local supplier uses A36 steel. So that's what we defined all the material to be. And that's all they carry. They carry it in different mill grades, whether it be pickled and oiled or it has a regular mill scale. Around here, most of the shops that are close to me, we live in NASCAR country, and they won't buy anything with mill scale on it. So it's most of the stuff they get is pickled and oiled. So that's what we're going to use. So we'll go back over here to the simulation workspace. So now the material's been done. Now we need to do the structural constraints. It's going to be constrained on this top face where it's attached to the ceiling, and then on this bottom face where it's attached to the concrete. And that's it. So we hit OK. So now we have those constraints done. So moving back over to the right, now we need to do the load. We're going to place the structural load on this face and on this face. And this time I believe I have it defined right. And we're going to put a 200-pound is what we guesstimated the heaviest thing to be. And it's probably way lighter than that because me and my brother can pick it up. Everything that we've taken off the lathe, we've been able to pick up with just him and me. And 200 pounds, when you think about it, is a lot of weight. So we'll hit OK. So now the contacts, and this is where it defines that calculates the contact types between the bodies and the components that overlap or touch each other. So when we hit automatic, it wants to know how far of a space do we have to create, or how far away does a part have to be until it's determined to be touching or part of that assembly. And in this case, it's 4 thousandths, which is, sheet of paper. So we're going to go ahead and generate that so it can the Fusion 360 can prepare all that stuff. And this time we got a green check mark over here. So everything, the study setup has all the information required. So we're going to go ahead and solve it. And we're going to do it locally. So let's hit solve. And hopefully my computer does it fairly quickly. I haven't done it with all the live stream software set up and going or anything like that. If you have any questions, feel free to pop them in the chat. I'll try to answer them. I am by no means an expert on this. I'm just a guy that works in a shop that likes to piddle around, and that's what I do. So let's see, still going. Working hard at it. So let me go over here and check something right quick. Oh yeah, looking good. Wow, it is really thinking, isn't it? That's the way it goes. I heard my fan just kick on the computer, so it's thinking. So let's say, do we fail? Oh, we failed. Oh, we're close though. 2.82. We want a 3-to-1 safety factor, which is, the general guidelines. Of course, this is overly dramatic here. So what you do here, the deformation scale on the safety factor is adjusted, so you want actual. So it gives you a better understanding of what the deal is here. So it points out where the weakest spots are. So let's see right up here. So it's all on this top part here. I wonder what we can do to stiffen that area up. I think the best thing might be just run a plate across the top 10 or 12 inches and then see what that does, if that gets us over our 3-to-1. But everything else looks good. So let's go back out here. Let's see what the stress is. All that stress is right there on that upper part. Right there. So as the weight's wanting to go on the end down here, it wants to pull this apart, which makes sense. So let's look at the displacement. How far down does it bow? A little over ½ an inch. So let's close this. Let's go back over here to the model, and just to see, let's see. We're going to add a support to the top here. So I'm going to right click on here and create a new component. If you slow left click it, it'll let you change the name, and we'll name that, let's see, boom support, boom plate, something like that. Let's call it boom plate, since I already have a boom support. And since it's branched off of the main part up here, it knows that I'm still going to use A36. So let's see, how can I do this? We're going to create a sketch on this plane right there. So I'm going to draw a line from here to here, and then from there down this way 10 inches. Zoom out here so I can get all this in here. 10 inches. And then from the line from here to here, and from here to there. So is that on my line? Oop, didn't make it quite to the outside here. So let's back up. We'll draw a line from here out to here, and then from here to there. There we go. Now we've got that done. So now let's create our plate. You hit Q for press pull, and you have to select all these areas, and we're going to go up 0.125, an eighth of an inch, because that's the plate that I have. So what we did, we just added an 1/8 inch thick plate, which I'm probably going to take a cutoff piece. Let's see, of the parts washer that I had left over. Yeah, Lewis, I definitely could use another beam up there. I'm trying to keep it thin up here so I don't lose. I only have 8-foot ceiling height, so I'm trying to stay away from stuff hanging from the ceiling. So let's just try this. This ought to be close. So I'm going to save this drawing, and then we're going to go back to the simulation space. Let's get it back to where we know it at. We have to redefine our contact sets since we added all those on there, or added that plate to it. And thanks, for Lewis, for that tip on the creating the split face. It really, really helped, and it made total sense. After I got done doing that stream, I said, well, that, you're putting the load over the whole area, so it doesn't make sense. And then as soon as you said that, it made total sense. So now that we have the contact set done, or the mesh done, it's good to go, ready to do the study. So we'll do it again. Solve the study. Maybe it won't take as long this time. Maybe it won't take as long. Who knows? Come on. It's thinking. Of course, like I say, anytime you do something live, it does it slow. It's about got it there. There we go. There we go. 3.24. So that's all it took for us to get within our 3-to-1 safety factor. And I'm very pleased with that. So I think it would have been all right before. But, if you're going to do it, you might as well do it right. So it's still showing the weak points there, but we're still well within our boundaries. So I'm happy. Very happy. So next, we got to order the material up and get this thing done. Let's see how far the displacement is. Still 0.5216. So what we were 0.53, so 10th, we didn't gain a lot. But that's what we're going to do. We're going to build this sucker. It's going to be the next thing on the list. Like I said, I got out the parts washer is done. Got to build the baskets for it. And then this crane, I could use it today. So it's something the shop could sorely need. So let's see, what else can I do? Oh, I wanted to show some stuff that Fusion 360 can do in their joints. When I was drawing this, I forgot to put a rotational joint in there. So I'm going to go back. I'm going to edit a couple of joints here. This one here, I'm going to edit that joint and make it a revolute joint. And the one on the bottom, do the same thing. Edit joint. Revolute. There we go. So when we grab this, that's how, oops. Of course, you got to make this one a rigid joint between them two, but you get the point. So that's how the jib crane's going to work. So it'll, it go 90 degrees from wall to wall. The parts washer sits here, the cleaning station sits here, and the sandblaster's right here. So we'll be able to lift it off the table, swing it into either the sandblaster or to the parts washer, the big one, and then the rinse table's on this wall. So that's a pretty successful drawing, I'd say, right there. So I'll get this thing, all the materials ordered up. Get my brother over here for a weekend. He just got done moving his daughter into her new house, so he's been busy on the weekends doing that. But I'll get him over here for a weekend to weld this. And he just ordered 2 Lincoln welders, and he hasn't even unboxed them yet, so we might break one of those out. And he really likes his stick welds when it comes to this big, heavy structural stuff. So we might break out his, I think he bought a TIG stick combination. I forget what brand it is. I know it's a Lincoln, but I can't, the 200, the pretty popular 200. And then he's got a big gas-powered one, but we don't want to run that one in the shop. So with that, I think we'll call it a night. Let's see. I think we got it all done. So, all right. Have a good weekend. Till next weekend, we'll see you. Good night.